So next up we have Patrick McFadden. Patrick has been at ThoughtWorks about 12 years at this point. Strong application development background. He's helped us open our Denver office. We've had a couple speakers here on this day from Denver. For the past, 5-6 years or so, Patrick's been working more on internal software platforms, infrastructure platforms. We've heard a few talks throughout today's conference around that topic, and two in particular around service mesh. So Patrick has a talk called Service Mesh as a Pipeline's Best Friend, showing the intersection of concerns like testing and some of the new infrastructure approaches. So Patrick, take it away.
Thanks, Brandon. Hey everybody, it's Brandon Sett. My name's Patrick McFadden, and today I want to talk to you guys about why a service mesh is a pipeline's best friend. And what I'd really like you all to take away from this talk, if nothing else, is you should get to know your service mesh technology. It can be your best friend as well. And it's going to really be like that Swiss Army knife inside of your operations toolkit. So starting out, let's go ahead and give us a definition of service mesh so we're all here on the same page. So a service mesh is a dedicated infrastructure layer that you can add to your applications. It allows you to transparently add capabilities like observability, traffic management, and security without adding them to your own code. And it's that last little bit that I want to tweak slightly and really focus on today. It's without adding them to your own application code, and that's going to be important to us later on. So how did we get here? Well, we used to build these kind of monolithic services, and if you had a product that needed to pull some ratings or some product details information, all of that happened in process. As we started to break up that monolith into these microservices architectures, we introduced the network into it and all the fun that brings along with it. And so now your product service is going to call this detail service or this rating service and get information back, you hope. Because maybe that service doesn't respond like you expected, or maybe it takes a little bit longer than you expected. And so you start writing in your application code to say, hey, if that doesn't respond, try again. Wait a second, try again. Maybe wait 3 seconds, try again. And you get this sort of this application code that you've got handling inside your HTTP client that's doing that all over the place. As you make more and more microservices, you have to have that code more and more places, hopefully not copying and pasting it around, but maybe re-implementing it in different ways and being a little suboptimal with it. So then we moved on with like Netflix and Twitter and others started to build these like language-based libraries, right? Like Hystrix or other things like that, where say, hey, as long as you're in the JVM, use this library, you'll be good. You can configure it, we'll handle retries, we'll handle circuit breaking, we can configure all of that and go, which is great, right? It's a really big improvement. The problem becomes now you're a little more tied to that language, right? Let's say you have a service you need to build that for whatever reason needs to be node-based or should be node-based, or maybe it's C-based or some other language. The barrier to entry there is now higher, right? You've got to rewrite that code or you've got to rebuild that library or something. And so while this is an improvement, there's better things to come. As we moved on to like Kubernetes, and we can kind of implement these sidecar patterns, where you have a separate application that's deployed along your application. We can deploy a proxy alongside our application, and it's that proxy that's dynamically configurable that you can change on the fly that really starts to unlock a lot of potential and interesting options for us. So as an engineer, you've got just a handful of things to worry about, right? And as we talk about shifting left and we're trying to bring security closer to you or operations closer to the engineers, there's a lot to pick up, right? And we want you to have more information so you can make better decisions at the point of change where you're making those coding changes. And as anybody that's maybe used a service mesh will tell you, it's a pretty big piece of technology. To debug it, sometimes you need some pretty deep network understanding. It's got broad functionality. We're talking about how do we handle MTLS between services, or header injection for observability, traffic shaping, all that sort of stuff that's happening inside of this service mesh, and it's a lot. There's a lot of documentation, a lot of features to learn and figure out. And depending on your setup, it might be a little harder to test locally, which means it's just all friction that's being added to the system that might stop you from wanting to invest your limited time in learning this technology. So why should you care? Well, this is dynamic and injectable configuration, and it allows for easier automated testing. And that's the piece we want to talk about, right? Is like that automated testing. How can we bring those automated tests, closer to the point of change? Actually check and see when we change something, does it have the intended outcome that I'm looking for? We've talked about some of the different error cases that you might see, those retries, or maybe the pulling from a cache if the service isn't there or isn't available. And it's important to test those things, and especially important to test those inside of your environment, your deployed environment, which may or may not be shared. And there's a handful of ways that I've seen people kind of start to test these error cases. Because if you don't test them, anybody that says, I have a disaster recovery plan, but I've never exercised that disaster recovery plan, well, that's unfortunately not really a disaster recovery plan that's going to help you in any way. So it's important to execute those tests, execute those plans, and it's no different when we're talking about how do we handle circuit breaking, or how do we handle this retry logic, or what happens when we need to invoke those sorts of things. So a couple of the ways that I've seen people try and test them, which is good, right? Anything you're trying to test, excellent, keep going. So the application logic for the specific cases. That could be application logic or data itself. Maybe some mocks. There could be scheduled downtime, which will differentiate a little bit between that and kind of chaos engineering. Or the proxy that we were talking about inside of your service mesh. So let's take a fairly simple set of microservices here. We've got a product page, the details service, and the reviews service. So you want to test these error cases. And you say, OK, when the product page calls the details service and there's an error, or there's a slow response time, I want to do something, right? Maybe I just won't show the product details. I'll just collapse that section. Or maybe I'll pull from a cache. So to test that, I'll write some if statements in there that says, hey, if the user that I'm testing with is Jason, then go ahead and just act like it errored out. That's good, right? You're testing something that is better than nothing, for sure. Unfortunately, now you've got this test logic that maybe you don't ever intend to actually execute in production inside of your production artifact. And so then you're either recompiling or rebuilding your artifact to be different for production, which is a bummer, or you've got dead code that you don't ever expect to use inside of production. So that's not easier or better either. Alternatively, right, maybe the details service says, we'll handle that for you. You call us with JSON, we'll respond with an error. But then everybody across the organization's got to figure that out and got to keep track of, Jason's special in details, but maybe Kimmy is special in reviews, and I can't remember exactly which way it goes. So that can be a little unmaintainable as well. You might deploy a mock service, right? This is a step up. You're testing the network. You're going to go actually hit a service. You've built your beautiful 12-factor app. Its config is removed from your code. And so you say, I will point my product service at my mock details service, restart it, and then I can call it. I can have latency added or whatever. Again, this is a big benefit. You're actually not changing your production artifact. You're making use of the benefits of that 12-factor app. But then do you build one mock service for all of the different producing services you want to consume? Or do you have many different mock services that you need to build? It again, becomes unmaintainable or just a little more suboptimal. I've also seen people say, hey, third Thursday of every month, that detail service just won't be here. Maybe in the afternoon it's going to be slow, too. And while, again, that's a really effective test method, right? That's good for, that's what's going to happen in production, right? That detail service may not be there. But now you make a change maybe on the third Friday of the month, and you've got a whole month of lead time before you actually get to test it. And so again, we want to find ways to bring that closer to the point of change, and so you can get those fast feedback cycles. And as you have more and more services, it doesn't really become maintainable to say, OK, details gets third Thursday, reviews gets second Thursday, and then you get this one and that one and the other one. And actually, we never have our services up at all over the month. And I do want to differentiate this before this is not chaos testing, right? Where the detail service might randomly go away. That can be highly effective. But again, you make a change trying to handle when the detail service is down. And then you're waiting for a random occurrence of the detail service to be down to test it. When it doesn't work as you expect, it's a long feedback cycle. So again, we want to find ways to bring that into the pipeline, to bring that closer to the point of change. And so that's why we'll talk about this proxy. We've got a QR code here. I've got some open source code where I kind of show this happening inside of a pipeline that I encourage you to go check out. So this is where the big benefit of the proxy comes in. With a little bit of configuration here, you can see that I'm checking for the header of JSON there on lines 16 through 18. I can apply this after I run my happy path tests and say, hey, when Jason tries to hit the reviews service, let's give him a 500. And that means that in your shared environment, your business stakeholders that are maybe running some tests or some quality engineers that are doing some exploratory testing, they're not affected by the tests that you're running. They're not affected by the configuration that you're applying. This is only going to be for your functional test. You can apply it before you run it, log in with it, and then move on. And here's, again, another example, or an example of that using ThoughtWorks testing framework Gauge, backed by Tycho. You can see here that we have kind of the first test scenario is the happy path scenario. And then for the second one, which I've tagged as error, I'll be able to sign in as JSON and check, in my case, it's pretty simple. There's an error getting your product reviews. But again, you might test that section doesn't even show up, or maybe that there is some cached information available in some other way. And so again, the benefit here, if you go read documentation for some of these service meshes, they'll show you how to do all these things. And it's really effective. And you go and you type it out in your command line, and you see it work. And it's great. But oftentimes, you don't get or take or see that next step of hey, this could go in my pipeline. And if it goes in my pipeline, then it's going to happen more frequently on every change or before every deployment or whatever cadence you have it set up as. And again, you can run Gauge, then you can apply that error testing configuration that's only going to be affecting your specific your test case. Then you can run your error tests and then clean up afterwards. It doesn't require you to restart the service. It doesn't require you to take down everything and everybody. It's just tightly focused on your use case. So again, this is just one simple example of how the service mesh can be effectively used inside of a pipeline. There's all sorts of things that you can do with it, and that's why I want you to go out and check the documentation and understand it and figure out how to run it locally so that you can do these really interesting traffic shaping methods, these really interesting deployments that help you build more repeatable, maintainable, scalable microservices. And so with that, I encourage you to go check out the code, scan it, check it out, let me know what you think, raise some issues, and get to know your service mesh. Use it in your pipeline. Thanks, everyone.